Here's our Math 158 homework discussion. And we're starting on page 433. And the first problem is number 15, the fourth root of 1296. Okay, I have my calculator here, so I can go on to here and look for the 12th root of 1290, or the fourth root of 1296. Now, there is a fourth root button on there. It's sort of hard to find. I like to think of this as 1296 raised to the 1/4 power. Remember, roots are on the bottom. So I can do it that way, or if I want to do that as a decimal, 1296 raised to the 0.25 power. 0.25 is a quarter. So I can do it that way. And on my calculator, I do have a caret, which allows me to do the exponents. So 1296, here's my caret button here, raised to the, if I'm using 1/4, I have to put it in parentheses. I do get the answer. Or I could do 1296 raised to the 0.25 power. Then I don't need parentheses. This calculator does have a way to do fourth roots. You have to hit 4 first, and then under the math menu, find this option 5, and then you can just put in 1296. I would investigate the calculator you have. You want to be able to get these roots easy, quickly. These are probably not typical test problems. It's really just a test of calculator usage to get you used to it when doing homework. Okay, let's go down through a couple of other problems. Number 23. Number 23 says the sixth root of -32. And what you're looking for here, you see this is a negative radicand, a negative number, and it's an even index. And whenever you have that combination, this is not real. Not real. And you can just stop right there. If you had your calculator and you actually wanted to look at it, I suppose we can put in the -32 and then try raising it to the 6th power. And the calculator says, oh, not the 6th power, the 1/6 power. So let's try that again, Joe. So we have -32 raised to the 1/6 power, right? Because the roots are on the bottom, so this would be the same as -32 raised to the 1/6 power. Remember my Azalea Bush story. And the calculator does say non-real answer. Okay, but again, I can do this without a calculator. Okay, a little bit deeper into the problem set. Problem number 31. 31 says the opposite of the cube root of -27. So first of all, we should probably talk about that. The cube root of 27 is 3 because 3 cubed is 27. The cube root of -27 is still valid. This is an odd index, odd, so there's no problem here. This will work out to be -3 because -3 cubed does give you -27. Okay, so this bit that I've circled up here is just the number -3. The problem says take the opposite of the cube root of -27, the opposite of -3, which is 3. Okay. We're not going to worry about the graphing problems. Skip 41, 47. Jump down to 49. Number 49. And again, most of these you can do right on the calculator. This says the square root of 12 squared, or if you want the square root of 12 times 12, notice there's a pair of 12s. The index is 2, so that just comes right out front as 12. Number 57. We have the opposite of the 6th root, and then in parentheses here, I've got -5 to the 6th power. So you might be a little concerned here with the even index and the negative number there, but when we have -5 raised to an even power, to the 6th power. That is going to be a positive number. So it looks like the way I would deal with this, I still have the opposite out front. I got to not forget that. I've got the 6th root of 5 to the 6th, right? Because negative 5 to the 6th would be negative 5 times 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 negative 5. And if you just count 1, 2, 3, 4, 5, 6, there's an even number of negative signs. So that's the same thing as 5 by 5 by 5 by 5 by 5 by 5. Okay, so that's what I wrote here. And once again, you see the, here's the continuation of the problem. We've got 5 factors, or 6 factors of 5 down here, and we're looking for groups of 6 because this is a 6th power, so that just comes right out in front, and we get negative 5. The thing that you will probably be careful of, if you're not, you'll lose it. That negative sign still stays in the problem. So it's the opposite of 5. A little tricky. Let's jump down to 61. Okay, so for 61, you've got the square root of negative z squared. Okay, so let's see, negative z squared is negative z times negative z, which we know is a positive. Negative times a negative is a positive, so that's z squared. So this problem now is the square root of z squared, like that, okay? And the one thing you have to look out for is this is not equal to z. We mentioned this in class. The square root of z squared is the absolute value of z. Absolute value of z. Okay. 67. So number 67. We've got the 6th root of x to the 30th. Okay. Okay, so once again, we have this problem sort of similar to here, where you've got an even index and an even power. We've got an even index, and we've got an even power there with a variable. So what we're going to do is we're going to think, I'm not going to write out 30 factors of x. We've got the 6th root, and we've got x to the 6th, and x to the 6th, and x to the 6th, x to the 6th, x to the 6th, and x to the 6th, right? 1, 2, 3, 4. I guess I only need 5 of them. There, x to the 6th. So 1, 2, 3, 4, 5 x to the 6th is the same as x to the 30th. So I can pull this out front, but even then I still have to keep the absolute values. So this is going to be the absolute value of x to the 6th. If you look in the back of the book, they also allow this. This is also correct. The absolute value of x to the 6th. Okay, so either one of those would be fine. Again, the problem is the x is not a number. We don't know whether x itself is positive or negative. Okay, number 71. Number 71, we have the square root of 9, 4, 8, 3. And the directions here say, find a decimal approximation, round each answer to 3 decimal places. So this one we do need a calculator. And so we'll do the square root. I do have a square root button, which comes out very nicely. 9, 4, 8, 3. And so here's the approximation, but they do say to 3 decimal places. So we have the 97.380 0.06964. This is actually irrational. That will continue on 3 decimal places. So let's see, this is tenths, 100ths, 1,000ths. So we're going to end up with 3 decimal places. But before we write down 97.380, we have to look at the next place after 3. If that is 5 or above, that's going to bump this one up 1. So what I'm going to write is 97.381. Interestingly enough, many calculators will allow you to do that automatically. On this particular calculator, it normally gives you floating decimal points, but if I push it to 3 decimal places and then try the same problem, I'll just try the same problem and it rounds it for me. Okay, 97.381. Play with your calculator, see how it works. Number 79. 79, it says the 4th root of 100. And again, I can do this on my calculator. I'll do this as 100 raised to the 0.25 power again. And there's my approximation. So 3.162. If I go back and put it on floating point, which is probably what your calculator would do, and I try the same problem, I get that. Notice that the calculator gives me 162.27766, and I'm looking for the 1,000th place. This is the 10th, the 100th, the 1,000th. I always have to look at the next digit over. If this is 5 or more, I round up. If this is less than 5, I just truncate and just chop it off, and that's my answer. Okay, so 3.162. Calculator usage. Number 87, this was my little C story that I told you. Number 87, we have distance is given as the square root of 2h. Distance is in miles, and height is in feet. And if you read the problem, it says a person whose eyes are 6 feet above ground level is standing on top of a hill 44 feet. So the hill is 44, and the eyeball is another 6. So that's a total of 50 feet. The feet is going to be 50 right there. And then I have to figure out how far that person can see. So the distance is going to be the square root of 2 times 50, which is the square root of 100, which is 10. Okay, so this person can see 10 miles to the horizon. Okay, and that's it for section 8.1. Let me see how long, 13 minutes. I'll stop this one and put another one together for 8.2. Have fun.